So my name is Rackel San Nicolas, and I'm a senior lecturer at the University of Melbourne. And I came to talk to you today about calcined clay, but as an overall, I'm a specialist of sustainable concrete and their durability. So I've been working in a lot of different type of materials with a different type of raw material and how we can make concrete out of it. For a whole range of different type of concrete. So I'm mainly working for the University of Melbourne, but I'm also working with Arup as a senior engineer in the material team. So today, really the topic of today, and I would really try to keep that in 10 minutes so like that I will be able to answer to as much question as I can. It's about calcined clay. What is it and how, and is, does it have a future in there as a sustainable option for the concrete in Australia? So, I mean, we are all aware of this. So there are introduction slides where, we've got a problem with cement, especially in concrete. There's not concrete that has a problem, and due to the high carbon emission and the fact that we are consuming a lot of it. There is a lot of solution in order to decrease the embodied carbon of concrete from the design to actually the material that we are using. And there's a lot of solution in carbon capture and alternative fuel, and a lot of things can be implemented in order to reduce the embodied carbon of concrete itself. So I listed here like few key action, but I'm sure you will be able to add some more there. What I'm going to talk to you about today is really how we can use less cement in our concrete formulation and how we can use other, calcined clay as an alternative. So our current option in order to, as alternative to cement or supplementary cementitious material, we are using slag and fly ash. And unfortunately, slag have a supply limitation. We're already importing a lot of the slag that we are consuming in Australia, but we are fortunate in a way because we still have a lot of fly ash, and we'll be able to use some for a few years. However, we know that coal power station will close, and so it means like fresh made fly ash won't be out anymore, and so we'll have to find ways to recycle what we have in storage, and it involves process and cost and more embodied carbon as well on the fly ash, because at the moment it's quite low due to the fact that it's a waste material. So where I'm heading at is like, okay, so we've got the slag, we've got some at the moment. However, in 5 to 10 years, we won't have that many, and a lot of people want slag. So it's going to be a hard market to get more slag and use that as ACM in our formulation. And fly ash, as I said, we are quite fortunate, but we don't know for how long. And they are estimate 2030, 2040. So I'm not going to go and give you a number there. And yes, So what is calcined clay? So where is it at in this whole picture, right? So what is it first? It's basically clay that we are calcining in low temperature compared to the temperature that we are using to make cement, that's for sure. We are at 650, 750, depending on what technology you are using. And basically we transform clay-rich soil in a component that is called calcined clay, and is active. So it's active. It's active like a pozzolan, and so it makes the same kind of reaction than a fly ash when it's in a binder system. And those products, that's when you calcine. So you calcine clay, and you've got these products. It are actually sitting under the new standard AS 3582.4. So the of supplementary cementitious material. It's qualified as a pozzolan and a manufacturer. So we already have in Australia a standard that qualify those materials, which is good. That's the first step before being able to use it in concrete. So I just put here a picture. It's like this technology and using calcined clay in concrete has been done overseas for quite a while, and that's one of the examples here. You've got one of those beautiful bridge that, and they have been using 35% of calcined clay in the formulation of concrete to design for this bridge. So they are full-scale application. We are not just only in the lab, especially when you are considering international work that has been done on the topic and usage of calcined clay as an SEM in concrete application. So that's just the point that I really want to make. We are fortunate somehow in Australia because we've got a heap of clay. So that's few maps of Australia where you can see that you've got a high percentage of clay in some region. That's why it's much more brown. And here, what is another type of information? There are different clays, different type of clays, and the one that is the most active, the easier to be transformed and used in concrete is Calcinated clay. And you can see that we are again fortunate because on the edge of Australia, especially, we've got a lot on the top soil, so really at the top. So we've got abundance of this material, and everywhere in Australia. I'm not just talking about Victoria, where we are at. In Victoria, that's the quantities that has been estimated. So it means that we've got clay. If we mean to transform it and use it in concrete, we've got enough supply for the next 500 years or more. However, I mean the point here is not to dig all the backyard to have some clay in our to have some make calcined clay for our concrete. It's like there is a lot of different supply that we can use, local supply. So here is just a map of Victoria where you've got already mined clay. But there is a lot of clay that is actually waste stream from other industry, right? So like wet clay from the brick industry that is not pure enough and just for brick application and just put on the side as a waste material. There is excavated clay and soil from, here I've got the Melbourne Metro, but a lot of infrastructure project where we are excavating a lot of soil. There is a lot of clay-rich soil that can be used as calcined clay as well, especially in concrete application. We are not targeting ultra-pure source of clay. We are actually, you will see through the screening that usually we are performing, we don't need an ultra-pure clay. So there's a lot of byproduct from sand quarry that are available, and I'm going to show some results there. Overburden and etc. All those materials can be used as calcined clay, and that's an important point, and that leads to how we select the material that can be used, how we transform it, and how that are valid to be used. So, and that's a good story around circular economy as well. Look at that. So the sustainability assessment of calcined clay. So according to the data that we have, so we've got here the region of like cement slag can be from low to high depending of where you get it from, especially because if it's locally sourced and it's from our steel industry, it's fine. But when you have to import it, it's going to come from much further. Fly ash, as I said, you know that we've got it's a low embodied carbon attached to a fly ash per ton, and calcined clay is about in this region, so it's in the region in between both somehow. Just a little bit more information on the sustainability of calcined clay. Most of the embodied carbon of the calcined clay is due to the calcination transformation. I put here a picture of one of those calciners, and you can see that 85% of the embodied carbon of calcined clay is actually due to the calcination. It's not transport, it's not grinding, it's not extraction. It's really it's the calcination. However, still we are in the low end within the range of slag and fly ash. This is just a result of a study when you are estimated. There are several clays, Australian clay that has been gathered and tested, and we done an analysis of it. And basically, if you are substituting about 20% of the cement in concrete by calcined clay, you are reducing by 15% the embodied carbon of your concrete per ton. So the process of calcined clay is really simple, and I really summarize it here. Basically, you collect the material, you usually dry it, you've got a grinding phase, and then the calcination. Depending on what technology you are using for the calcination, sometimes you have to have another grinding afterwards. But as I said, usually the whole whole bulk of the embodied carbon is due to calcination. So I just put some pictures of some of the samples that we have, which actually real sample that we have collected from different quarries and how it looks like after. So you've got range of color, and I'm not going to talk too much about color, but that might be a point as well later on. So just for you to be aware, we've got in total at the moment, we've got data on around 80 samples overall Australia of different clay that has been analyzed. We usually push them through a screening analysis with different methods in order to see if there is enough in those clay-rich soil, if there is enough clay actually, because there is sand usually and other type of clay mixed it up. So about 60% of those 80 samples have enough clay in the sample to be able to take further and to be analyzed. So that's what we've done in order to have a wide set of samples, because even though the technology have been tested overseas, what we really wanted to know is what's going on. Is Australian clay are the same? Are we working in the same range? Can we work with them? What is the difference, and etc. As there were no data about it. So there's a lot of potential formulation using calcined clay. Formulation of concrete, obviously, that's what I'm talking about. And when I say a wide range, it means that calcined clay can be used as substitution of cement, like 10, 20, 30%, just straight substitution by weight, and has great durability performance there. It can be used as well, and I'm sure you heard about what we call LC3, which is a mix basically with calcined clay, limestone. That is the mix of the two is substituting cement. You work between a range between 20 to 50% of substitution there. And we can go all the way far along with 100% of substitution of cement and have some kind of geopolymer system and different binders. Actually, a lot of the technology around geopolymers and alkali activated material has been developed based on calcined clay product at the beginning before moving on to slag and fly ash originally. So a few universities are working on the topic. Of course, the University of Melbourne, but UTS, DKN, RMIT, UQ, UNSW, and UniSA, and they are all part of the Australian network for the advancement of calcined clay. And so I just put a few pictures there to show, what it looks like. And we've got a lot of partners as well that are interested and want to use the material and try to develop this technology. So I cite a few partners here, like different cement companies, like road authorities, also some potential new suppliers who have the material or can transform the material and are interested. And we've got support also from CRCs. CRC in order to develop the technology. So maybe just a really quick overview on what kind of performance those materials have. So here I just pull out some from the literature. On the left-hand side, there is a wide range of compressive strengths in respect of the amount of calcined clay that you are putting in your system. The kaolinite content, that is in the calcined clay in your system. So the system is always the same. It means it in this system it's an LC3 with 50% of cement that is substituted, not by calcined clay only, but by calcined clay and limestone. And the richer the kaolinite, your clay is, the better performance it is. However, you can see that even when you've got very low amount of kaolinite in your system, you still can reach a 40 ampere. That's really what the point I want to make. Depending on the application that you are targeting, you can actually reach proper properties. Here are some results that we have on Australian clay. What is interesting to have a look is we don't have really a delay at early strengths, depending of the clay, especially when you are comparing to a reference or comparing to a fly ash mix with 30% of fly ash. We are within the range, and you can see that we can reach very nice compressive strengths later on as well. So we've got a broad spectrum of compressive strengths. I just wanted to mention this project to talk about how pure needs to be the clay or where it needs to be from it's like this. This project is was led by Arup. It's in the real project in London, where they have been able to recycle excavated soil and London tunnel clay in order to be able to make sample and test it and in LC3 kind of system. But there were two LC3 system, one with 50% of the cement substitute and another one with 70% of the cement substitute by a combination of limestone and calcined clay. What is interesting is, depending on the target and the application, there is a lot of potential of this material, and you can substitute up to 70%. It's still in the cement system to have an okay or good kind of application. So that's really a project, and what I like is really through the tunneling, they had this material, they wanted to make use of it instead of just putting it in storage, and that's really where the story is from and what we can do with this kind of technology. Similar project is actually off the ground right now, is starting in Victoria with the North East Link project and the Alliance with the CRC Building 4.0 and the University of Melbourne. Just I touched here on the durability, and I will be able, if you want to have a conversation with me on durability of this kind of system, I can have it. I just put two different representation here. One is about the shrinkage. Some of the system with Australian calcined clay and shrinkage, there were a beautiful study from UTS that is showing the fact that it tends, depending on the type of clay you are using, you can have a slightly more shrinkage or a little bit more, depending of where you are at and at what time you are assessing the deformation of your concrete. So that's something that we need to keep an eye on, definitely. And then in respect of compressive strength, water porosity, chloride migration, gas permeation, usually the performance of this type of system are better. In respect of carbonation, as with slag and fly ash, we can have a long conversation about that. It tends to be slightly lower. I just want to touch the performance in respect of the durability of the workability, because I have often this question. What I want to say is, like, depending on the system that you are working, you can improve the workability of a calcined clay system. Usually when you are using, if you are grinding too much the material, you will have too much fine, and it will be water hungry, and you will have to put a little bit more of superplasticizer in your system. However, it's those parameters that you need to control. So in order to be able to have a nice flow, and I've got a few pictures here with a reference with only cement and a calcined clay, where we improved, we increased by just 0.2 the amount of superplasticizer, 0.2% the amount of superplasticizer in the system in order to reach similar workability. So really, it's possible, and there are off-the-shelf superplasticizer that actually do the job. So finally, I really want to talk about the challenges of the supply chain of calcined clay. So basically, today, we don't have any suppliers in Australia, right? There are international suppliers, but who wants to import calcined clay at the moment? It's also another challenge that we have. It's hard to get the material calcined. So we identify many sources of very good material that can be calcined. However, we don't have the facility at bigger scale to be able to calcine the material. We do, but it's hard to get the material calcined from those companies who can actually do it. And why it's important, it's really what we want to make the point. It's really in order to be able to prove and do like feasibility and accelerate the technology to be in the field, we need to have full scale trials. And I'm sure I'm not the only one who thinks that. And that's really what unlocked like geopolymer technology and all of that. And it's really like to showcase that it's doable at full scale. And the final point that I have here is about the fact that we need to develop, there is guideline, but we need to develop an easier process in order to select the material, especially as you saw that there is a wide range of material that can be used. So it needs to be, there's some guidance that needs to be developed in order to allow to pre-select the material before using it. So I just put on the right-hand side here an interesting document on the attractiveness on how to implement calcined clay in it. I mean, this study is European, but basically it gives you several scenarios and what are the kind of investment and depending on the technology and how like how many years it will take you in order to pay back your investment. So, which is very interesting when you are talking to potential new suppliers who want to invest or develop this technology. There are many different studies and initiatives that are on the roll right now. There are initiatives with companies and industry partners like MRPV, as I said, Major Road Project Victoria, and Northeast Link, and Arup, who are supporting and working toward developing having full-scale trial in order to demonstrate the feasibility of the technology. Many collaboration of the university and the industry through ARC and CRC and LEAF grant project. On the right-hand side here, you've got a picture of the pilot that will allow to calcine the material at bigger scale and allow those full-scale trial and structural application to be happening. And finally, I just have a point here. There is the Australian Calcined Clay Advancement Network that is formed where a lot of university and industry are participate too. And if you want more information about the network, please send me emails. But what it is like basically it's really in order to develop guidelines and what are all our missing information in order to be able to develop this technology and have maybe a technical specification as we have on geopolymers and what are we missing, and we are gathering a lot the information from everywhere as well in order to everywhere in Australia in order to also develop more accurate process of selection and of the raw material to be used in calcined clay. So that's it. I think